Next, we have Jonathan Regehr from Garmin, who will be talking about handling secrets in your cloud-native architecture and how your secret backend can peacefully coexist with VMware Tanzu Application Service. On to you.
Hi, everybody. Glad to be here. I hope that we have a great time together here. I don't know about you, but man, I have sure enjoyed the talks that I have been a part of so far today. Let's get started. Okay, you should be seeing my screen here. So off we go. So again, our talk today is about handling secrets in your cloud native architecture. Real quick about me. I've been in IT for 20 years. Really, I'm not old. That's a thing in the head, not the body. Hope you get that joke. I've been a platform architect at Garmin for the last 2 or 3 years. I've been in software development as various flavors of app dev. For the rest of my career, I've been at Garmin for 9 years, and the last 4 years, I've been a part of the platform team at Garmin. I'm a founding member of the Tanzu Vanguard, woohoo, formerly known as the Pivotal Vanguard. I'm a dad to 3 boys and 2 cats, and I'm a husband. Our goal today is to look at how we can deliver secure, robust, and automated application credential storage to our cloud native applications. Let's talk role real fast. So, our role, whether we are IT managers or developers or Linux admins or DevOps people or platform administrators, is to innovate and automate. I want to look at 2 roles a little more specifically because I think it really informs the why about what we're doing here. So Garmin hires developers with the sole purpose of obviously writing software and pushing to production. It Meetings and things get in the way, and I think it's a good reminder for all of us that this is what we hire software developers to do. As a platform operator, I want to remove as many roadblocks from my developers as possible, and I want to make the haiku that was coined by Ansi Fakuri as true as I can possibly make it. Here's my source code, run it on the cloud for me. I do not care how. Now, when we come to secrets, that should also be true. I don't care how I get my secrets as long as they're where I need them for my application to run when it starts. So that kind of informs where we're going with our goal. We also want to make sure that we are we're enforcing and abiding by corporate standards. So that's another thing we're going to probably talk about. So we have some alternatives for how to get secrets into our applications. The first alternative that we're going to talk about is creds and property files. I'm kidding. Don't do this. This is bad. It's not secure. It's not robust. It's not automated. Next, we want to look at user-provided services. When Garmin first started down our cloud-native journey, this is where we immediately went for secrets. It's very simple. User-provided services are just static information that is provided and injected into an application at runtime as a service. And so it's an easy place to put credentials. It's robust because of its simplicity. However, it is not automated. There is no automation around getting those credentials rotated, and it's not secure. As an application developer, if I have developer access to the platform, I can create a user provided service, which means I can also see a user provided service, which means I can leak credentials. So we don't want to do this if we can get away without it. Next option is vendor provided solutions, and your mileage will vary here. I'm going to unshare for a second and kind of go down memory lane a little bit on this topic before we move to where we really want to go. So our secret backend of choice offered a solution for service or for injecting secrets into our applications, and we decided to explore that as our next place to go to make our credential management more automated. It worked really well for some cases, but it was clear to us quickly that it was not a long-term solution and it wasn't properly cloud native. So when we talk about applications in general, specifically if we're talking about VM applications, the lifecycle is pretty simple. You deploy code, you run code, you start your application, and you stop your application. However, in a cloud native environment, there are 2 more lifecycle steps that are really, really important. One of them is scale, and the other is restart or disaster recovery. So the solution that our vendor gave us basically put the application in the position of responsibility for getting their secrets. So it didn't always line up with cloud native principles. What they offered was a solution where the service that would provide a token and a URL to the application, and then the application had to get its own secrets. Now, there's various flavors of tokens that you can that your secret backend might offer, but tokens are designed to be short-lived. So your application, when you first deploy it, it's going to start, no problem. But what happens down the road? Let's say you deploy on Tuesday and on Friday you experience a high load, your application scales up. Now you're 4 days away from that deployment, and your token may or may not still be valid. So now you have an application that can't scale. Heaven forbid there are failures in data centers. Let's say one of your availability zones goes down. The platform is going to do what it was designed to do. It's going to take the applications running in the availability zone that goes down. It's going to move them to a different availability zone. Again, no token, no secrets, no start. So that's not cool. We don't want to do that. So your mileage may vary, but that was the experience that we had. And it presented a lot of challenges to us. So we found that the vendor provided solution wasn't the best thing for us. Let's go ahead and share again. So we're going to stay, oops, go back to the right thing here. There we go. We are going to stay away from vendor provided solutions. So what does that leave us? Oh, so real quick, we talked about secure, robust, and automated. Our vendor solution, it was definitely automated. It was not very robust in all cases that we needed to care about. And it wasn't terribly secure. I'll show you in a little bit, but the credentials themselves weren't leaked, but it was easy to leak the ability to get credentials, which is kind of the same thing. So where we want to go here is a custom service broker. Our custom service broker is going to integrate your secret backend with CredHub. Excuse me, CredHub comes as part of Pivotal Application Service, Tanzu Application Service, whatever we want to call it. So you are probably saying, well, hold the phone here. I have a secret backend. It's a corporate standard. Why do I need another one? And ironically, when CredHub first started, it actually kind of started as we want to be the be all end all secret backend. And then they quickly realized this isn't a good idea. We don't want to take over the standard. So you see the soon joke here. CredHub kind of went there and then they're like, well, nope, we're going to back off. And that's what we want to do here. We're not adding anything to your corporate standards. We're not trying to say we're bringing a new secret backend to the table. What we are trying to do is use your corporate secret backend and put a temporary copy of those credentials into CredHub specifically for a single application during its lifecycle. The next time a version of that application pushes, you get a new set of credentials. So we still treat your secret backend as the de facto standard. We're just putting something in front of it that makes life on the cloud a little better. So again, our goal here is to keep our apps cloud native. We want to build 12-factor applications. We want them to be service agnostic. Whether your backend is Vault or Iconic if it has an API or some other secret backend, we don't want our applications to know about that. We don't want to have to code our applications to be specific to our secret backend. We want specifically to honor the third of the 12 factors, which is store configuration in the environment. We don't want to be using an environment variable to go get configuration. We want to have it stored in the environment. We also want to constrain complexity. So again, whatever your secret backend is, it may or may not have been developed for cloud native applications. It may or may not have weird nuances about it that you don't want to tie into your applications. We want to abstract those away from our applications. We don't want to have to worry about that. And again, we want to cover full application lifecycle support. That's really, really important. You do not want to be woken up at 12 o'clock on a Sunday because your application suddenly has a whole bunch of load and it can't scale. That's a bad time and you don't want to be there. I've been there and I didn't like it. Okay, so again, we are building a service broker. Now, what's a service broker? In simple terms, this is just a Spring Boot app. I'm sure you'll hear the word start.spring.io from Josh Long in a little bit later today. That's where we're going. That's where you start. You go get a Spring Boot app. You can also get the pre-made one from the Open Service Broker API. That Open Service Broker API, by the way, is honored by Cloud Foundry. It's honored by Kubernetes. And I believe there may be some other OSB API platforms. The beauty here is as long as you honor that OSB API interface, your service broker can be reused on different platforms. And it's going to allow us to have loose coupling between our app and its secrets. So really what we're doing here, we're talking to two different backends. We're talking to our Vault or our service broker backend, and then we're also going to be talking to CredHub. So we're going to divide the next couple of minutes into two different sections here. We are going to talk about communication between the broker and the backend, and then we're going to talk about communication between the broker and CredHub. So your backend has only one single requirement that must be true. You have to have an API. HashiCorp Vault has a fantastic API. So if that's your secret backend, awesome. They also have a CLI, works really, really well. So that CLI allows the developer to do lots of debugging, and especially if you're a platform operator, that CLI is really, really helpful. But again, not required. As long as your backend, or as long as your secret backend has an API, you're golden. The next thing we need to do is we need to plan our layout. So this is how the secrets are laid down on the backend so that they're easy for the broker to collect. So this is where you probably have some corporate secret sauce with how those things are laid out, and you're probably going to have to put some of that into your broker for how to translate an application in Cloud Foundry to your secret backend. You may want to consider following the TAS org space app model. That hierarchy lays secrets out really nicely, and it gives you great ability to pull the right secrets at the right times. You may want to consider a separate master space. If you run some automation around your credentials, which we'll talk about a little bit later, you may want to have a master secret space and then a place where you copy down to an app space to store your secrets. Also, you want to plan for unique and shared secrets. Some things might have a unique secret. Maybe as you automate things more fully, every single application gets its own database credentials, or maybe they share database credentials. Either way, you want to plan for that. Lastly, and most important, you want to trust but verify. So the point here is you don't want to allow a developer to put some funky stuff in their application configuration or in their environment variables and be able to steal secrets that are not intended for that application. This is where the bind request comes into play. So that Open Service Broker API gives you a bind request that contains the application GUID for the application requesting the bind. You can use the Cloud Foundry APIs or the Kube APIs to take that app GUID and inspect where that app lives. You can get the org that it lives in TAS, or you can get the space that it lives in. In Kube, you can get the namespace. Now you have a hierarchical set of information that you can use to make sure you are getting the correct information. The other challenge that we had with apps, we pipeline all of our applications, and so an application name isn't quite as simple as I would hope. So my shopping cart isn't called shopping cart. It might be called dev e-commerce shopping cart build number 1 or build number 20. So there are times where you have to parse out a little bit from that application name to get a hold of the true app name that you want to pull secrets for from your backend. What we are going to move toward to make that easier is tagging. So this does allow, again, a developer to put a tag into their application, and then we're going to use that information. Now that, of course, does add a little bit of risk because somebody tries to get cute with their tag name, they might be able to get secrets that aren't intended for them. But again, we're building that hierarchy of information. We have the org, we have the space, we have the app. So they might get a different credential from their own space, but they're not going to get someone else's credentials. So very small risk of leak, but not very much, and it brings a lot of convenience to the table. Okay, so now we have secrets that we've pulled out of our backend. Now we need to get those into CredHub. So again, there's an API here, super easy. It's really, really, really secure, but as long as you're inside the Cloud Foundry network, it's just an API. So it's not that bad to work with. The other important thing here is you got to set permissions. So The CredHub API requires that you give permissions by the application GUID, and then it uses that information when someone comes to read those secrets. The last thing we're going to do, that OSB API return, or you get the binding request, and then you get to return something. So what we want to return here is a CredHub ref, and that's basically a tiny URL sort of thing that just represents a path in CredHub where our application lives. Okay, so we talked about how we're going to build the broker. Due to the security of this, unfortunately, we don't. I'm not going to be demoing today, but I do have some examples of what these things look like. So we're going to go back to our approach a little bit, and we're going to start with user-provided services. If you were to use those, your environment variables would look something like this. Okay, so you can see here in the services that I get for my application environment, I get a user-provided service with credentials, and those credentials are plain text and they're visible. So if I'm a developer, I can get those off the platform. So there's a high potential for leakage. So here is a vendor-provided broker that is doing the same thing, except it's not the user-provided service where the credentials are just set there. The vendor-provided service gives us a URL where we can get secrets, and it also gives us a token. So in some ways, this is a little better. The secrets aren't sitting here, they're not visible. But as a developer, if I can get this information, I can go get secrets. Some brokers take it one step further and they use a role where the application gets a role and then they have to use that role to get a token and get their secrets. That's not good either, because if I can steal that role, I can get credentials all day long, not just until this token not until this token expires. So we didn't feel that this brought a lot of security to the table. Okay, so we've talked about what we don't want to do. Now we're to where we want to go. We've built ourselves a CredHub broker, and I want to walk through the flow of how this works. Now, this looks a little scary when we first peek at it, but it's really not that bad. And we're going to walk through it real quick, and it's pretty straightforward. So at the first step here, we have an application that is going to bind. Hopefully, my mouse is showing on the screen here. Oh, it's not. Let's move over here so you can see it. Where is it? It is. Look at that. Okay, my bad. All right, so time one, our application is pushed to the platform. It makes a service binding request. So we send that binding request to our service broker. The service broker then inspects the request, builds that hierarchical information tree that we talked about. And in our case, it uses that hierarchical information to get a token to our secret backend, which in this example happens to be Vault. We use that token to pull secrets for our specific application. You can see that right here in step 3. Now, our secret broker has some secrets. We haven't put them anywhere yet. We just have a hold of some secrets. So what we do with those secrets is we write them into CredHub right here. And at the same time, we're going to use the app GUID, which again, we got from our bind request. It's not a difficult thing to get once we have our bind request. We're going to use that application GUID to give permission to our application to read those secrets. And the last part we're doing in step 4 here is that bind request requires a bind result, and that bind result is going to return a CredHub ref. We went above and beyond and returned one more thing for debugging purposes. We returned the path in Vault where we pulled secrets from. That information is only for debugging purposes. It's not used by the application. It's not used to couple the app to our backend. It is merely there for debugging purposes. That's it. That's all the broker does. That's all the code that you as an application developer or as a platform operator have to worry about. Now you do see 2 more steps here, and those steps are actually taken by the platform itself. So now we have an application that has been pushed and built. We have secrets lying in CredHub, and our app is ready to start. So the platform then does its magic. It decides what cell to run the application on. That cell begins to start the application, and as it's starting the application, it hops into the environment of the application and sees, ooh, this guy has a CredHub ref. Okay, I got work to do. So then step number 5 here is that the Ego cell, the underlying runtime in the platform, reads that secret for me out of CredHub, and then it injects that secret into the application runtime environment in a way that as a developer, I can't see it. And so those secrets, the application comes up and it has all the secrets it needs to run. I forgot to start my timer, so I apologize for looking at my watch. I want to make sure that we keep on time here. Okay, so this is what happens when, as a developer, I look at the environment for an application that is using CredHub to get its secrets. You can see under the credentials here, I get a CredHub ref. Again, it's sort of like a URL or a path where those secrets live, and that information was used to inject secrets into my runtime application. Again, here I have a vault path, and that vault path is just for debugging purposes. There's no dependency on the application and the secret backend. That's only there so that as a developer, if I have a problem, I can go, okay, what secret backend was used, what path was used. We can verify that the secrets that the application has are the ones that we expect. There were lots of challenges as we moved down this journey. So the first one, debugging CredHub is really hard. Like I said, CredHub is really, really secure. It's buried inside of the Cloud Foundry or Tanzu Application Service runtime. It's hard to get to. If you have east-west firewalling in place, it's impossible to get to unless you have the ability to get on a jump box. So as a platform admin, this was no problem for me. I could get to CredHub when I needed to debug it. It took some hoops jumping through some hoops to get there. But as a developer, it ain't happening. Nobody's getting to CredHub. So those secrets, while they're stored in CredHub, are safe. Vendor lock-in was a challenge for us for a little while. As you saw, we tried the vendor-provided broker, and it didn't work out real well for us. We ended up with vendor-specific code in our applications and applications that were responsible for getting their own secrets from the backend. Those things didn't work out well, and we kind of learned as we move further down the journey that the best interest of a vendor might not be the best interest as yours. We had a few calls where it was difficult to glean, like, okay, are we doing something wrong here, or is this a vendor trying to protect their interest? So keep your mind open for things like that. We have 2 minutes left, and I want to cover what I call the bigger picture here, and that is credential lifecycle management. So the goal here is to automate credentials, not just automate putting them in an application, but automate the whole flow of credentials. This is where you're really, really going to see some amazing stuff and where it really benefits your organization. So what the next steps you want to look at are building a management system. That management system is going to allow application developers to tie their application to the specific secrets that it needs. And then the management system can lay down those credentials in for preparation for that app being deployed and the broker pulling the credentials for you. The next step in that train is automated credential rotation. So let's say that you have you rotate quarterly or weekly. You don't want to have every application developer have to restart anything when their application when their credentials are rotated. You want all of that to be handled. So our credential ecosystem goes to its services, creates brand new credentials, writes them down where the applications can use them, and then we use a Cloud Foundry plugin, or Cloud Foundry CLI plugin called BG Restage, which essentially creates a brand new copy of a running application, makes sure it's healthy, and then applies all of the configuration to it so that that new application runs just like the old one. It also rebinds all of the services. So if you remember, that bind request is when we get secrets and copy them to CredHub. So as we run a BG restage, we get brand new copies of all our credentials. We get automated rotation. We also have tracking. So again, remember, we're having application developers tie their apps to their secrets. So we know exactly who's using what credential and when, and we can make sure that we rotate all of the right things before we delete or destroy an old credential. Whew, that was a lot of information. I hope you're still with me. I hope you enjoyed the talk. Again, my name is Jonathan Regehr, and I will see you guys in the questions in just a couple of minutes. Thank you for your time today. Recordings, I think, are going to be available in about a week, and you'll be able to pull these links and get more information on the different things in the presentation. Thank you.
Thanks, Jonathan. That was great. And yeah, as Jonathan mentioned, head over to the Q&A and feel free to just like chat or ask questions based on the talk.